Hello, folks. We are back again for some more note-taking. This week is a little bit more notes heavy than I generally prefer for it to be, so I do apologize for that. We're just getting in some more content this week before we wrap it up. Today and tomorrow will be our last lectures of this week and of this unit, and then Thursday will be a review day. So we are nearing the end of all of these lectures. So today we are talking about human populations. If you are following along with your student notes, which I very much hope that you are, you can find where we're picking up today on page 14, where it says AP Environmental Science age structure diagrams, because that is where we are starting. So pause it, take a second, find those notes. If you don't already have them, make sure you have something to write with and write on in case you think of questions so that you can come to one of my live sessions during office hours every day, or you can hold on to those questions and when we do our review day on Thursday here in a couple days, you'll be able to ask your questions then. And that will be helpful, I think. So let's dive right in. Oh gosh, I forgot where to put myself. So, population structure can generally be shown with these age structure diagrams. They're basically just visual aids that show the distribution of males and females in each age group. So you can see that the way that they have this divided up here, actually I think it says it better down below, the way they have this divided up down here, they've got pre-reproductive ages being 0 to 14 years old, reproductive ages being 15 through 44, and then post-reproductive ages, meaning after your reproductive time period, being 45 and up. Not necessarily saying that's the time when most people are having children, just that that's the time period, the reproductive age being the time period that most people are able to theoretically have kids. So that's how they've got that divided. So this is what these age structure diagrams are actually going to look like. We looked at this a little bit in our yesterday's notes. So we looked at a little bit of age structure diagrams, but we're going to dive a little bit deeper into that today. You can see if a country has more young people than old people, its age structure diagram will be wider at the bottom. That's going to be a population pyramid. So it makes sense, right? Like all three of these would technically be population pyramids because they are wider at the bottom than they are at the top. Now the far right one is a declining population. So that's a little bit different, but population pyramids just means that there are more young people than older people. That's pretty typical of developing countries. So you can see these two, they're slowly expanding. These two categories, like Guatemala, Nigeria, Saudi Arabia, also the US, Australia, and China, they're expanding, whether it be rapidly or slowly. But in more stable populations like Japan, Italy, and Greece, it's pretty much leveling out. Maybe smaller at the bottom or smaller at the top than it is at the bottom, but for the most part, it's starting to level out. And then declining populations are obviously going to be smaller at the bottom because the bottom half, this is representing the younger people. So they're not reproducing as much. And it makes sense too, as it says in your notes, the wide base, meaning this wide base at the bottom down here in the red and yellow, indicates that the population is going to continue to grow even more because a large number of women that have not had children yet, but are potentially able to. So as it says on this slide, population momentum is just the phenomenon where populations keep growing after birth control policies or voluntary birth reductions have begun to lower the CBR of a country. The CBR being birth rate. So even when birth control policies are put in place, or even when, say, like there's just a trend in that country, a trend for people to not have as many children, somehow that population continues to grow from that momentum. So total fertility rate, this is really the meat and potatoes of what we're talking about today. Total fertility rate is just going to be the average number of children born to women in a population. So, for example, if most people have between 1 and 2 children, then total fertility rate would probably be like 1.5, right? Just the average number of children born to a woman. You can see that where do I put myself? The fertility rate in less developed countries is much higher than the fertility rate in more developed countries, where there is higher levels of industrialization and income. We tend to have less children. So you can see where I think this data looks like it only goes to about 2010, and they've got a projection. The dotted line is just where they're projecting where it'll go in the future. But birth rates are going down around most of the world as a whole. So the total fertility rate that is required to offset the average number of deaths in a population and for the current population size to remain stable is called replacement level fertility. Now, it's literally exactly what it sounds like, right? Just the number that would be required to keep the population where it's at while replacing the people who are dying. Yeah, too far. There are a few things that really affect the birth rates and the fertility rates around the world. And it makes sense once we talk through this, you'll see how that makes sense, that lower income and more developing countries tend to have higher reproduction rates. And there are a few reasons why. Some of them listed here. Children are used as part of the labor force in a lot of the world. If you have a kid, that's great because that's more labor that you can have in whatever industry you're working in or around the household. The cost of raising and educating children, please hold. Okay, cool. So the cost of raising and educating children obviously varies quite a bit throughout the world. The availability of private and public pension, so private or public health, or not help financially. Urbanization, so the building of infrastructure and industry, as well as educational and employment opportunities for women. Again, other things that are affecting this include the average age of a woman at the birth of their first child, the availability of legal abortions, the availability of reliable birth control methods, and then also religious beliefs, traditions, and cultural norms. So all of these things play pretty large roles in the birth rates in various countries and various parts of the world. So life expectancy should seem pretty obvious, right? The average number of years that an infant born in any particular year in any particular country can be expected to live, given the current average lifespan and the death rate of that country. So people are living longer than they used to, which makes sense. And why is that? There's an increased food supply and distribution. So we've got global food trade now, right? We get avocados from Mexico. We get fruits from South America. We get food from all over the world. So it's better distributed, which leads to number 2, better nutrition. Medical advances, obviously. Back in the day, if you had a peanut allergy, you were out, like done. You weren't going to live very long. Nowadays, you got a peanut allergy, here's an EpiPen, and you're going to be fine. And improved sanitation. The Black Plague, the cholera outbreaks in centuries past could have been avoided. Excuse me. Could have been avoided if people just knew, like, hey, maybe throwing your urine and feces out the window instead of, like, disposing of it properly, maybe that's going to pollute our water supply and, cause us to all get cholera. Now we know that, and we don't do those things. So improved sanitation is a huge benefit. We live a lot longer because of that. So tied into that life expectancy is also the infant mortality rate. This is just the number of deaths of children under 1 year of age per 1,000 live births. So this is not to be confused with the child mortality rate, which we're going to talk about next. So it's important to know the difference between the two. Infant mortality rate is specifically under 1 year of age because they're an infant, which makes sense. So the U.S. actually has a higher infant mortality rate than most developed countries, which is something to note. As of this data, which appears to be from 2012, we were at 6.6 deaths of infants per 1,000 births. The global infant mortality rate is 46 per 1,000 births. And you can see throughout the globe, based on this chart, how certain areas have higher mortality rates than others. Things that lead to this are things like inadequate health care for the poor. So in countries, including the U.S., the quality of health care that you're able to receive depends on how much money you have. Things like drug addiction, which can pretty heavily influence a child's survival rate if they're born and their body, their system is already addicted to anything, as well as teenage pregnancies. So like I said, we can't confuse infant mortality rate with child mortality rate. Child mortality rate is going to be the number of deaths of children under the age of 5 per 1,000 live births. So if they're under 1, it contributes to the infant mortality rate. If they're between 1 and 5, it contributes to the child mortality rate. So sometimes the life expectancy and infant mortality can differ wildly for a certain part of the country. Excuse me. So you can kind of see how that plays out along our chart here. The under 5 mortality rate in developing regions is much, much higher than that of developed areas. So now looking at the globe as a whole, right? Oh, can I hide this? Nice. Good to know. Should have known that a long time ago. Looking at the globe as a whole, if you go back 2 to 5 million years, you can see that there were not very many humans. This is based on billions of people. If you look over here to the right-hand side, and then time is listed at the bottom. So it goes all the way back to the hunting and gathering era, all the way up to the agricultural revolution, the Black Plague, which is so cool. I mean, it's not cool. Like, a lot of people died. It's not cool at all. But just for one singular event to have such a massive impact on the global population numbers it's wild. And you can see that right there on our chart. There was a literal dip in the entire world's population because of it. We were starting to have a little bit of an incline right here when right after the agricultural revolution. We were going up, population was getting bigger, and then boom, we go way back down because of how much the Black Plague affected everything. So then we're moving back up. Then the Industrial Revolution happens, and it changes everything. Human population spiked like crazy. And this data looks like it hit in the early 2000s, so we're not quite too up to date on it, but it's kind of, they've got question marks here, right? We don't know what the human population is going to do. We are already at 8 billion people in the world. That number has been passed. We are past 8 billion 8 billion global citizens at this point already. And so that leads us to the question of how long can the human population keep going, right? How long can we just keep adding more and more people to the earth? This is a question that Thomas Malthus asked in 1798. He was one of the first people who was like, hey, what's going on here? We got lots of people and not that much earth. So Thomas Malthus saw that societies through history had always experienced things like epidemics, famines, wars, events that mask the fundamental problem of populations overstretching their resource limitations. So we've got a lot of big words in that, right? But essentially, there were things that would always knock the population back down, kind of like kill a good number of people, knock the population back down. And so his argument was that those events were kind of covering up the issue of populations eventually pushing past their resources. Hello? No, thank you. Deepest apologies. Okay. So he started asking questions about things that people hadn't really asked about before, like overpopulation, overconsumption. Is technology going to increase human carrying capacity? Are we going to keep innovating and designing and causing people to live longer and things like that to the point where the human carrying capacity just doesn't exist, right? How many humans can the Earth support? And can we edit that number based on our own technology abilities? And then finally, can the human population grow indefinitely? I don't think so. There are certain things that we've been doing, and I'm sure you know where this is headed, but there are certain things that we've been doing that have been pretty devastatingly affecting the Earth itself to meet the needs that we have as a population of 8 billion people. And a lot of that comes from degrading natural capital, coming from altering nature to meet our needs. So we have heavily reduced biodiversity. Like it's rough. We've increased our use of net primary productivity, increasing genetic resistance in pest species and disease-causing bacteria, things like antibiotic resistance. Oh, shoot. I'm pausing. 1 second. Alrighty. So sorry for that delay. I had a meeting. This is my planning right now that I'm recording. And I had a meeting to go pick up my teacher card so I can buy cool stuff for the classroom. So picking up where we left off, we do have a tendency to increase genetic resistance in both pests and disease-causing bacteria. So things like antibiotic resistance, things like pest resistance, pest species in things like crops and the produce that we eat. We've eliminated a lot of natural predators. So that's going to, as we talked about during trophic cascade and things like that, we tend to mess up natural populations pretty heavily. We've also introduced harmful species into natural communities. Fun fact, the domesticated cat causes, they've already caused the extinction of more than 30, I think it's 32, different species of birds and small animals. Because cats are not native to the U.S. And so we get them and then we let them hang out outside, and now things are going extinct because of it. We're using even renewable resources that can be replenished. We're using those faster than they can be replenished. We're heavily disrupting natural chemical cycling. So when we talked about biogeochemical cycles, we talked about the carbon cycle. We are throwing things way off with our carbon emissions. And tying into that, we rely mostly on polluting and climate-changing fossil fuels. Humans are the worst. So the human population has the ability to either grow, decline, or remain stable. This is where it might start getting a little bit more complicated. So if you were only half listening before, maybe mostly listen now, because this is where it can get a little more complicated and we do start getting some numbers involved. So pay close attention now, please. So population change is going to be based on births, deaths, and migration. Births and deaths also sometimes being referred to as fertility or mortality. So keep that in mind. Population change is going to be, and it's pretty self-explanatory, right? Births plus immigration minus deaths plus immigration with an E. So immigration with an I being people coming to that place, immigration with an E being people leaving that place. Either way, deaths and immigration, obviously those are people departing, whether the life as a whole they're departing from or just departing that country or area of residence. So that's how you calculate population change as a whole. Crude birth rate and crude death rate, that's going to be the number of live births divided by 1,000 individuals a year. So, and then crude death rate would just be the opposite, number of deaths per 1,000 individuals per year. So the global growth rate is going to be the CBR minus the CDR divided by 10. So looking back right here, crude birth rate, sometimes called CBR, crude death rate, sometimes called CDR. So if you see those acronyms, that's what they're talking about. So the global growth rate is going to be the crude birth rate minus the crude death rate divided by 10 for the globe. The growth rate for a nation, any specific country, births plus immigration minus deaths plus immigration with an E divided by 10. And then you've also got doubling time. Let me catch up and see where we are in the notes too, if you're following along. Hopefully you are following along because there's some good information in here. Okay. So at this point, we are on page 20 in the center of the page here. Doubling time is just the number of years that it takes for a population to double, assuming that the growth rate is constant. So assuming the growth rate is pretty steady, the doubling time is the number of years it will take the population to double. And the way that you calculate that is just 70 divided by the growth rate. And that's going to give you a number in years. Cool. So the dramatic increase in Earth's human population in the last 200 years has happened because death rates have been declining more rapidly than birth rates, which makes sense, right? The death rate goes down, the birth rate goes up, population is going to get bigger. Also, here lately, women are having fewer babies, but they're not having few enough to stabilize the world's population. So despite the number of babies being lower, it's not low enough to stop the global population from continuing to explode. Currently, replacement level fertility rate, remember what you already talked about, is just the number that would keep the population constant and steady. Replacement level fertility rate is 2.1 in developed countries and up to 2.5 in developing countries. Some issues with rapid population decline have been happening here and there. And there are some reasons that can happen, starting with problems that occur from that. Sorry, I'm trying to multitask. It's going great. It can threaten economic growth. There can be a shortage in the labor market. Not enough people able to work. Less government revenues with fewer workers. Less entrepreneurship and new business formation. Less likelihood for new technology development. Public deficits. Pensions cut. Retirement age increased. So populations can obviously decline if the death rate shoots up, which is what happened with the AIDS epidemic. From 1981 to 2009, 27 million people died. This caused a really sharp drop in the life expectancy worldwide. That's how big of an influence this epidemic had. It is the leading cause of death for people ages 15 to 49. And because many young adults die from AIDS, it causes populations to lose their most productive workers when they're at that young adult age where they're supposed to be thriving. I don't know, I'm at that age, don't know if I'm thriving, but you know what I mean. That most productive stage of life. And so you can see the breakdown here, the red part of this age diagram being people who did have AIDS, and the yellow part being people without AIDS. So half the population in some of these age groups did have AIDS. So women and fertility. The factors that are most clearly and most closely related to the decline of birth rates are increasing education and economic independence for women. Pretty darn cool. Those are good things. In the demographic transition model, which is what we're about to start talking about, the lower death rate of the second stage is usually the result of increased levels of education. And now that statement might not make a lot of sense right now, but as we go through these next few slides, hopefully it will. Educated women find that they do not need to bear as many children to ensure that some will survive, and they might also learn family planning techniques. So family planning is just the regulation of the number or spacing of offspring through the use of birth control. So that's going to be essentially just, I think an easier way to look at it is just women, specifically women, taking control over their ability to reproduce and saying, like, I'm going to not reproduce anymore, and I'm going to make that choice for myself and my family. And so family planning has become more common across the world. Especially become more common in developed countries. Less developed countries, I'm sorry. It is responsible for a 55% drop in total fertility rates, which is pretty huge. The financial benefits are money spent on planning. I gotta slow down. My brain's going faster than my mouth can talk. The financial benefits include money being spent on family planning saves far more in health and education costs. So while previously people might have thought, oh, I can't afford any more kids, but I also can't afford birth control. In this case, people are realizing, okay, well, if I am on some sort of contraceptive and I'm not having more children, that will be more financially beneficial to me in the long run than having another child unexpectedly. An example or a small case study in this. Let's go up here. Slowing population growth in India. Okay, so India's population in 1979 was 671 million. And then by 2012, it was up to 1.2 billion people, which is a 180% increase over that 1979 population. Some things that cause this: bias towards having male children. So when people had a daughter or 2 daughters or 3 daughters, they when people had a daughter or multiple daughters, they would keep having kids until they had a son because there was a bias towards male children. Poor couples wanted many, many children. And only 48% of couples used family planning. And remember, family planning, which we talked about previously, is just the regulation or spacing out of offspring through birth control. By most estimates, India is actually going to go past China as the world's most populous or populated country by 2027 or earlier, when the country's population is expected to reach 1.4 billion. The government does provide financial incentives for sterilization operations. As of right now, 37% of India's female population has undergone sterilization, and 1% of the male population has undergone vasectomies. So these are just measures that countries take to try to slow down that population growth. You can see propaganda about this. 1 is fun, population control, girl or boy, 2 is enough, things like that. So the top 12 most populous or populated countries in the world, China is number 1, but like we just said in that previous slide, India is coming up close behind them. And this is in the millions over here on the side. So the U.S., as of the publication of this graphic in 2012, I'm sure it's much higher now. As of 2012, this graphic states that the U.S. is at 307 million people. So those first 2 countries have more than the next, 10 combined, really. 20% of the population consumes 50% of the Earth's resources. Take a second and think on that. 20% of the human population consumes 50% of the Earth's resources. Does that statement make it sound like we are existing in a sustainable way right now? Are we existing in a way that things are going to be able to carry on like they're going? I don't think so. In this other graphic on the bottom right, we've got our ecological footprint compared to the different countries. Tell me why. Humans, man. Tell me why India and China, while being the 2 most populated countries in the world, by far, are only the 3rd and 4th countries with the highest ecological footprint. Somehow, despite the U.S. being the third most populous country, the U.S. has the highest ecological footprint. And it could be argued that because we are a more developed country, that might have an effect, but still, that's rough. We are triple the global average for ecological footprint. A term you might need to know for this section is just affluence, having lots of wealth, such as money, goods, or property. You might hear people use this word in regard to like, oh, well, Mountain Brook, Alabama is a very affluent area because there's a lot of money there. Affluent just meaning wealthy. So a fifth of the world currently lives in extreme poverty. Something to think about. 1/5 of the world currently lives in extreme poverty. Graphics to look at here about that. And when we're talking about wrapping it back or bringing it back around to what we were initially talking about here, is things like life expectancy, things like fertility rates, reproduction, population growth. But when you think about the fact that 1/5 of the world is living in extreme poverty, obviously living in poverty is going to affect people's lifespan. That just makes sense. We've already addressed that in most of the world, including the US, if you are poor, then you are much more likely to die of something that could have been fixed in a hospital. But you're less likely to go do it because you're living in poverty. So something to think about not only in the US, but also around the world. So in total, and I don't know how old these graphics are, but 1 out of 9 people don't have access to clean water in the world. 12% of countries meet the target for child mortality. 16% of countries meet the targets for access to sanitation and access to drinking water. Every 20 seconds, a child dies as a result of poor sanitation. Malnutrition effects up here. Things to think about that all affect mortality and population. So I mentioned earlier that we were going to talk about demographic transition. This comes in 4 stages, and we're going to kind of break these down really quick. Stage 1, pre-industrial, stage 2, transitional, stage 3, industrial, and stage 4, post-industrial. So we're going to look at what each of these entail. So stage 1, and if you look at our chart down here, you've got birth rate and death rate, number per 1,000 per year. Total population being this teal color, birth rate is red, death rate is blue, and this is the growth rate over time as we go left to right. So the birth rate's very low on this side, birth rate is very high in the middle, low again, and then declining. So in stage 1 of the pre-industrial stage, the population is going to grow very slowly because of a high birth rate that is compensating for infant mortality and a high death rate. So in this stage, infant mortality is still high. So people are having a lot of kids because you don't know how many are going to survive because infant mortality is high, right? Stage 2 is going to be the longest stage here. The population's, it's transitional. The population's going to be growing really rapidly because the birth rates are high, and then the death rates start to drop because of improved food production and health. Stage 3, industrial, the population growth is going to slow down a little bit as the birth rate and the death rates start to drop because of improved food production, health, and education. Because like we said before, having higher levels of education in women especially leads to a lower birth rate. Stage 4, post-industrial, population growth levels off and then declines as the birth rate equals and then falls below the death rate. So eventually the population is going to stop reproducing quite as much. I'm apparently very fidgety today. I'm so sorry. So breaking it down a little bit more, phase 1, slow population growth. This is pre-industrial. Nearly a steady rate, high birth rate, and high death rates. Short life expectancy, high infant mortality rate. This is going to be the case for a lot of developing countries. Subsistence economy, meaning that most people there are farmers. There's a lack of health care. There's not good, poor sanitation in countries that are going through phase 1 of demographic transition. Parents rely on children to care for them in old age. It's an economic benefit to have children because maybe they're free labor. almost every nation at this point has moved out of phase 1. Just about every country in the world now is out of phase 1, which is very good. However, war, famine, disease, especially AIDS, the AIDS epidemic was hard and pushed a lot of countries back into phase 1. It has pushed some countries back to phase 1. Phase 2 is going to have rapid population growth. This is the transitional phase. The death rates are going down and the birth rates are going up, which is great. There's a large total fertility rate, TFR. In this case, you've got better sanitation, clean drinking water, increased access to foods, good, and healthcare, things like vaccines. That's really important. An example of a country in phase 2 in the rapid population growth phase would be India. Phase 3 is going to be stable population growth. This is industrial. The birth rates and the death rates decrease, so we're kind of steadying out. The economy and education system improve, income increases, children become an economic burden. So that's something to think about. Notice that in phase 1, children are an economic benefit. It's good to have kids because they're going to help you bring money into the household. But in phase 3, children have now become an economic burden. I saw a statistic not too long ago that said that having a child in the U.S. is going to end up costing you more than $100,000 in like the first year of their life. Children are very expensive now. And this is the case, this phase 3 stable population growth is the case currently for the U.S. and for Canada. Stage 4 is going to be declining population growth. This is post-industrial. Population is going down. There's a higher proportion of elderly people. Pension programs and Social Security start to get kind of strained. They're kind of struggling a little bit. And that makes sense because of that high proportion of elderly people. People need to immigrate in to care for the elderly. Generally, they have a relatively high affluence and economic development. Remember, affluence is wealth. So generally, these countries are fairly wealthy, and their economic development is pretty good. Recent studies have suggested that the total fertility rate increases after reaching a low. So examples of that would be Norway and Italy. And I think that's where we're at. I think that's where we're going to leave off for right now. This one is pretty heavy. There's a lot of content in a somewhat brief period of time, and there were a couple interruptions while I was trying to record this. So if this was unclear in any way, I'm so sorry. If you have any questions, like always, please either email me through Gmail or Schoology, or come to my office hours at 9 a.m., 10:45 a.m., or 1 p.m. I'm always logged into the WebEx personal room at those times. Or hold on to your questions, and we can go over them on Thursday when we do our review session before Friday's test. So I hope you guys are having a wonderful week so far, and I will be here if you need me.